Draw the graph y is equal x squared minus 6x plus 7. State the equation of the axis of symmetry. So first we have to draw this function. We have x to second power, so this is quadratic function. The graph of the quadratic function is parabola. Parabola can be open up or open down. Everything depends on coefficient before x squared. The general form of quadratic function is ax squared plus bx plus c. Coefficient before x tell us, like I said, x squared, if parabola is open up or open down. If a is positive, in our case, coefficient before x squared is invisible, so it's always 1. If we don't have any number, it's always 1. So a is equal 1. So is greater than 0, positive number, so parabola will be open up. To draw this parabola, we need also have the vertex. To find the vertex, I'll write that first coefficient is p, coordinates of vertex is p, the second coordinates is q. We will change our general form of quadratic function to vertex form. And let me remind you of this form. The vertex form is a times x minus p to second power plus q. We know that a is equal 1 from this form. So we need to find p and q. So let's rewrite this form to vertex form. We have y is equal, a is 1, so we don't have to write. Open parenthesis, always at the beginning is x. And now we have negative 6x, coefficient before x. We always have to take to this parenthesis, p is always half of coefficient of x variable. So half of negative 6, so it will be negative 3. Close parenthesis to second power. And next, what we have to do? We have only take this 2 first expression. And when we raise x minus 3 to second power, what will be x squared? Next will be negative 6x, and we will have plus 9. 3 to second power is 9, but we don't have this 9. So now we have to subtract this 9, and whatever we have left, we have to add this plus 7. So our function, we can rewrite that this is x minus 3 to second power, negative 9 plus, so it will be negative 2. Let's maybe remind you that how I get this. X minus 3 to second power square of difference, I use formula that this is, let's write maybe that this is d minus e to second power, this is d squared minus 2 de plus e to second power. This is formula for square of difference. To check if I get the right two first expressions, I use this formula. X to second minus 3 to second power, this is first expression to second power, minus we have 2 times first expression times second expression, and the second expression to second power. When we raise x minus 3 to second power, and when we subtract this 9, we have exactly the same what we have here at the beginning. The constant number we always add whatever we have. And now from this vertex form we can write the vertex of our parabola. First coordinates p is 3, and the second is whatever we add to x minus 3 to second power. So this is like, we can rewrite this x minus 3 to second power plus negative 2 we have. Positive and negative give me negative. So q is negative 2. We have vertex, parabola, on our parabola. We know that our parabola is open up. So what else we need to draw the graph? We need to find the points in which our parabola cross x-axis and y-axis. To find points of which our parabola cross the x-axis, we have to take that y is equal 0 and calculate what will be when y is equal 0. So wherever we have in our form of our function, x squared minus 6x plus 7 is equal 0. Quadratic equation, we will use formula that x1, 2 solutions for quadratic equation is negative b plus minus square root of b squared minus 4ac. This is formula for solution of quadratic equation over 2a. In our example, a is equal, coefficient before x squared is 1, b is equal, coefficient before x is negative 6, and constant c is equal 7. So we have to just substitute to this formula. So it will be negative b, so we have negatives and negatives, so it will be 6 plus minus square root of b to second power, so it will be 36 minus 4 times 1 times 7, so it will be times 7 only, over 2a, so 2 times 1, a is 1, so this is 2. So this is equal 6 plus minus square root of 8. So we will have square root of 8 over 2. So this is equal, we can rewrite that this is 6 plus minus square root of 8. So we can rewrite that this is 4 times 2 under square root over 2. So this is 6 plus minus square root of 4 is 2, and square root of 2 we will copy. Because square root of 4 times 2, we can rewrite that this is square root of 4 times square root of 2. Square root of 4 is 2, and square root of 2 we have to rewrite over 2. So this is equal, what else we can do? We can factorize 2 from numerator, so it will be 2 times 3 plus minus square root of 2 over 2. 2 and 2 we can reduce, so we have that x is 3 plus minus square root of 2. So we have the points in which our parabola pass the x-axis. For x1 will be 3 plus square root of 2, x2 will be 3 minus square root of 2. You can use calculator. So it will be 3 plus square root of 2, so this is 4.41. So let's round to the first digit after decimal point, so it will be 4.4. And the second is 3 minus square root of 2, so this is 1. We have 5/8. So again we write to the first digit after decimal point. So it will be, we have to add 1 to 5, so because we have after 5, 8 number greater than 5, so it will be 1.6. So we have 2 points, y is 0 and x first coordinate is 4.4, 0, and the second point is 1.6 and 0. We have 2 points in which our parabola cross x-axis, and how to find the value, the coordinates of point which our y-axis is crossed by our parabola. We need to now substitute x's by 0. X is 0, so y, what will be? 0 to second power minus, we copy 6 times 0. This substitute x's by 0 plus 7 we have, so it will be 7. So we have another point, 0, 7 coordinates. So now we have characteristic points, so we can draw the graph. we have y-axis, x-axis. So first, let's write the vertex. Vertex is 3 and -2. So let's find the unit. 1, -1, -1, 1. We have point 3, -2, 3 on the x-axis, so it will be 1, 2, 3, and on the y-axis -2, so approximately it will be here. This is our vertex, 3, -2 coordinates. Next, we have to add these 3 points to our xy coordinates. We have 4.4, so this is 3, 4, 5, so it will be approximately here. First point in which our parabola passed x-axis, and the second is 1.6, so here is 1, so 1/6 will be approximately here. So what next? We have point 0, 7, 0 and 7 on the y-axis. So it will be 1, 2, 3, 4, 5, 6, 7 approximately here. So now we have to just draw our parabola. It will be something like this. Our parabola must pass these points. Let's open up because coefficient before x squared is positive. We have the graph of our quadratic function. What else? We have to state the equation of axis of symmetry. When we have vertex of our parabola should be symmetric about line which pass our vertex and is parallel to y-axis, and this line passed this point. So x coordinate is 3. So this line, equation of this line is x equals 3. This line is parallel to y-axis. The line which passed our vertex, x equals 3, it will be the axis of symmetry of our parabola. So this is my solution.